Welcome, everyone. Today, we are diving into a fascinating and critical topic in artificial intelligence, humanity's last exam, commonly known as HLE. We will explore how we test the absolute limits of frontier AI models and see if they can truly pass the impossible test. Let's get started. Let's begin by defining the what. Humanity's last exam, or HLE, is a cutting-edge, multimodal benchmark representing the very frontier of human knowledge. The basics are straightforward but daunting. It comprises 2,500 incredibly complex questions. But why did researchers create such an impossible test? Over the past few years, we've faced a benchmark crisis. Standard exams like the SAT, bar exam, or basic coding tests are completely saturated by modern AI. They're simply too easy now. We needed a test so difficult that it forces an AI to prove its depth. How does HLE do this? By demanding PhD-level deduction and cross-disciplinary synthesis, often requiring the AI to analyze both text and complex visual data. In our deep dive today, we will see how HLE serves as the ultimate proving ground for frontier models like Claude Mythos Preview, determining if they are truly reasoning or just memorizing. This flowchart illustrates the evolution of AI testing. We start on the left with traditional AI benchmarks. Because models have become so smart, these tests are now saturated, creating a benchmark gap. To fill this gap, researchers introduced humanity's last exam. Notice how HLE branches into its core components, 2,500 expert questions and multimodal analysis. These strict requirements converge on the right, providing the new gold standard for frontier AI evaluation. To fully appreciate HLE, we need to understand the crisis that birthed it. The baseline for AI testing used to be simple logic and reading comprehension. But look at the escalation. Today's frontier models can ingest 1 million tokens, write complete enterprise applications, and breeze through graduate-level exams. This creates a severe limitation for researchers. When every top-tier model scores 95% or higher on a benchmark, that test loses all its diagnostic value. It no longer measures the ceiling of artificial intelligence, it just proves the model is competent. The solution is humanity's last exam. HLE is heavily curated by top academics globally to be virtually impossible for anyone who isn't a domain expert. It resets the grading curve, giving us a reliable metric to gauge the actual frontier of machine intelligence. Look at this comparison graph. On the left side, we see standardized tests yielding scores over 90% for multiple models, meaning all diagnostic value is completely lost. We can't tell who is smarter. On the right, we introduce humanity's last exam. Because it forces deep, expert-level reasoning, the scores spread out realistically like 40% versus 64%. This provides the clear differentiation that scientists need to track true AI progress. How does HLE actually stump these brilliant models? The secret is multimodal complexity. What does multimodal mean? It means the test requires the AI to seamlessly process and integrate different types of data, such as text, images, and complex diagrams. The basics of a question might involve showing the AI a dense snippet of a research paper right next to a complicated chemical structure. Why is this necessary? Because real-world expertise isn't just about reading text. Doctors analyze X-rays, engineers study blueprints, and financial analysts read complex charts. How do models tackle this? The AI must activate its vision encoders to understand the image, map that visual data into its text-based reasoning engine, and synthesize a logical conclusion. For our deep dive, realize that this multimodal approach prevents the AI from simply using a web search tool to find the answer in a text string. It forces genuine, cross-modal deduction. This process flow highlights the multimodal challenge. Notice how both a complex text query and a scientific diagram feed simultaneously into the AI reasoning engine. The engine performs cross-modal synthesis, integrating the visual and textual data. This leads to hypothesis generation, eventually outputting an expert-level answer. If the AI cannot bridge the gap between seeing the diagram and reading the text, the flow breaks, and it fails the question. When administering the impossible test, researchers must decide how to properly handicap the AI. We primarily use two distinct testing methodologies. Method 1 is no tools. Here, the AI is completely isolated from the internet. It must rely entirely on the knowledge baked into its neural weights. This tests pure, raw reasoning and recall. Method 2 is with tools. Here, the AI is unleashed as a fully autonomous agent. It can browse the web, write and execute Python code to solve math and manage millions of tokens of context. The results are incredibly revealing. Older models like Claude Opus 4.6 managed 40% without tools and 53.1% with tools. But Claude Mythos Preview established a new frontier. It scored 56.8% completely on its own, and a massive 64.7% when allowed to use agentic tools. This proves that giving a highly capable reasoning engine the right tools dramatically amplifies its expert-level problem-solving. This flowchart maps out the two evaluation paths. From the HLE evaluation starting point, we split into Method 1, no tools, relying on pure neural reasoning, and Method 2, with tools, allowing agentic web search and coding. Following the paths down, we see the distinct Mythos scores of 56.8% and 64.7%. Both paths converge on the ultimate conclusion, a massive capability leap over previous generations of AI. Now we must address the elephant in the room regarding all AI benchmarks, the contamination problem. What is contamination? It happens when an AI model accidentally ingests and memorizes the actual test questions during its massive internet pre-training phase. The basics are simple. These models scrape the entire web. If researchers discuss HLE questions on Reddit or GitHub, the AI eats the answer key. Why does this ruin the test? Because if the AI already knows the answer, its high score just proves it has a great memory, not that it possesses advanced, expert reasoning. Let's do a deep dive into the evidence. Anthropic's own researchers noticed that Claude Mythos performs quite well on HLE even when restricted to low effort, meaning it isn't given the computational time to think deeply. This strongly implies some level of data contamination and memorization has occurred. It highlights the modern dilemma. Keeping a digital test perfectly secret from an AI that reads the entire internet is remarkably difficult. Let's trace the contamination state diagram. The AI begins web scraping and ingesting data. Ideally, it goes left to clean data, forcing genuine reasoning and resulting in a valid score. However, if HLE questions are leaked online, the model enters the contaminated data state. This allows for memorized recall, where the AI succeeds with very low effort, ultimately leading to an invalidated score. This diagram shows exactly why data hygiene is critical in AI evaluation. To combat contamination during the with tools evaluation, engineers must get creative. The threat is obvious. If you give a super smart AI web access and ask it an impossible question, its first move might simply be to Google the answer key. To mitigate this agentic cheating, developers implement strict URL block lists inside the AI's web fetching tool. Look at the sample pseudocode on the slide. The system maintains an array of blocked domains, like lastexam.ai, Hugging Face, and specific GitHub repositories. When the AI requests a URL, the system checks for substring matches. For our deep dive, notice how specific this gets. The code normalizes URLs and actively blocks specific academic papers on arcs4.org that are known to discuss the HLE benchmark. Finally, there is a failsafe. We don't just trust the blocklist. We use older models, like Opus 4.6, to read the entire transcript of the AI's web browsing. If we catch it sneaking around the blocklist to find an HLE cheat sheet, we manually grade that question as incorrect. This sequence diagram shows the real-time mitigation of agentic cheating. The Mythos AI agent asks the web tool to fetch a URL. Crucially, the request is intercepted by the blocklist engine. If the URL contains forbidden HLE strings, the filter immediately returns an access denied error, forcing the AI to fall back on its own reasoning. If the URL is safe, it fetches the data normally. This ensures the integrity of the with tools evaluation. Why does passing an impossible test matter to the real world? Let's explore a vital real-time use case, frontier research and development. Imagine an enterprise pharmaceutical company trying to synthesize a novel protein to cure a rare disease. This is incredibly complex. The relevance of HLE is this: a model that can score over 64% on humanities last exam has empirically proven it can handle PhD-level, cross-disciplinary reasoning. In execution, the enterprise deploys this AI as an autonomous R&D assistant. They feed it multimodal data, thousands of pages of trial text, complex chemical diagrams, and raw datasets. Because the AI has proven its frontier intelligence, it doesn't just summarize the text, it logically synthesizes the data to identify novel chemical pathways that human teams entirely overlooked. The outcome is transformative. R&D timelines compress from years down to months. The enterprise isn't using a chatbot. They have deployed a tireless, world-class scientific colleague. Let's track this enterprise workflow. Raw R&D data is split into text from trials and images of proteins. Both feed directly into our HLE-capable AI agent. Because it has mastered multimodal synthesis, it successfully identifies hidden pathways. This immediately branches into accelerated drug discovery, culminating in years of R&D saved. The AI's success on benchmarks directly translates into massive corporate and societal value. So, what is the final verdict? Can an AI pass the impossible test? It hasn't achieved perfection yet, but Claude Mythos scoring nearly 65% with tools proves that we are rapidly approaching parity with elite human experts. However, the major caveat remains: we must be relentlessly vigilant about data contamination. We must ensure we are measuring true deductive reasoning and not just vast memorization. The broader paradigm shift is undeniable. Artificial intelligence has graduated. We are moving away from simple chatbots that draft emails toward autonomous, agentic systems capable of solving humanity's most complex scientific problems. As these models inevitably conquer HLE, the industry will have to invent entirely new, dynamic ways to evaluate intelligence. The future of technology belongs to those who understand these frontier models. To master these cutting-edge AI concepts, I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for joining me. Our final mind map summarizes the AI frontier. At the core, we have the HLE benchmark driving the need for multimodal reasoning. This requires strict evaluation integrity, utilizing block lists and contamination audits. When verified, this unlocks massive enterprise impact through accelerated R&D and autonomous agents. Finally, it points us toward future testing, where we must build dynamic frameworks that stretch far beyond human baselines.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks, like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft, you can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.